Okay, so we're going to be looking at multiplying and dividing radical expressions, section 5.2, and specifically today just multiplying radicals. So there's two things that you need to remember. When you multiply radicals, you need to multiply the coefficients and multiply the radicands, okay, separately. And the other thing you need to know is that you can only multiply radicals that have the same index. Okay, so they don't necessarily have to be like radicals, they just need to have the same index. So there are two approaches. In the first approach, we will first multiply, and then simplify. Okay, so here are our coefficients, 2 and 4. We'll multiply those together. Here are our radicals. We multiply those together. Okay, so that's going to give us 8 square root 525. And we're going to use the perfect square method. So you want to make sure that you find the largest perfect square that fits into 525, which is 25. And the other factor will be 21. And of course the square root of 25 is 5, which you can pull out of the bracket, and 8 times 5 is 40, and you're left with the root 21, so your answer is 40 root 21. The second method is where you first simplify, and secondly multiply. Okay, so we're going to simplify the root 75, okay, and 75 is 25 times 3. We can square root the 25 and we get 5, which we multiply by the coefficient of that radical, so 4 times 5 is 20. So now we've simplified. We have 2 root 7 and 20 root 3. And now we want to multiply the coefficients. So you want to go 2 and 20, so 2 times 20. And then you want to multiply the radicals, so root 7 and root 3. Multiply that underneath the radical sign, and you get 40 square root 21. Okay, so let's try a couple of examples. Okay, so in the first example, we are going to multiply negative 3 square root 2x times 4 square root 6. And remember our restriction, because we have an even index, our restriction is x has to be greater than and equal to 0. Okay, so we're going to multiply our coefficients together. And then we're going to multiply the radicals. Okay, so we're going to go negative 3 times 4 square root and then 2x times 6. So that's going to give us negative 12 root 12x. And we're going to simplify this root 12x. So we're going to get negative 12, and then inside the radical, I'm going to prime factorize. So I'm going to go 2 times 2 times 3, that's 12, times x. And because our index is an even number, 2, we're going to group our pairs. And we're going to take the 2 out. So we're going to have negative 12 times 2, and we're left with 3x inside the bracket. And so that's going to give us negative 24 square root of 3x. Okay, our next example. No variables to worry about on this one. And we also have a binomial. Okay, this is a binomial. Okay, so we're going to use the distributive property. We're going to multiply the 7 root 3 by 5 root 5 and the 7 root 3 times negative 6 root 3. Okay, so we're going to start by multiplying our coefficients. and then our radicals. So 7 times 5 is 35. The square root of 3 times the square root of 5 is the square root of 15, and then minus. And once again, multiply our coefficients, and then multiply the radical. So that will give us 7 times 6 is 42, and root 3 times root 3 is square root of 9. Okay, and then we'll do some simplifying because we know we can take the square root of 9. We can't simplify the square root of 15, so we'll leave that as 35 root 15 minus 42 times the square root of 9, which is 3. And so our final answer is 35 root 15 minus 42 times 3, which is 126. Okay, on to our next example. Now we have a binomial times a binomial. Okay, so coefficients. So we're going to use FOIL. Let's start with that. Okay, so we're going to go 8 root 2 times 6 root 10. And then negative 5 times 9 root 5 and negative 5 times 6 root 10. Okay, so 8 times 9 is 72. Root 2 times root 5 is root 10 plus 8 times 6 is 48. Root 2 times root 10 is root 20. And then negative 5 times 9 root 5 will give us negative 45 root 5. And then negative 5 times positive 6 root 10 will leave us with negative 30 root 10. Okay, we cannot simplify the 72 root 10, so we leave that. But we can simplify the 48 root 20. So I'm going to do that over on the side here. Okay. So 48 and then 20 is 2 times 2 times 5. Our index is 2, so we want to group in pairs. Pull the 2 out. We're going to go 48 times 2 and then root 5. So that leaves us with 96 root 5. So we'll put that back into the expression, 96 root 5. Okay, and the next two terms are already simplified. Okay, now remember from our last lesson, we can only add like radicals, okay? So we've got a 72 root 10, so a root 10 here, and a root 10 here, and we have a root 5 here, and a root 5 here. So we're going to go 72 minus 30 is 42 root 10. And 96 minus 45 will leave us with 51 root 5. Okay, our last example then, before we go on to our word problem, we have a monomial times a binomial. So we're going to use distribution. Okay. And this time our index is a 3. So W is greater than or equal to 0 doesn't count. Okay, because it's an odd numbered index and it doesn't matter whether W is positive or negative. Okay, so we're going to go 9 and then the cube root of 2W times the cube root of 4W leaves us with the cube root of 8W squared plus 9 times 7 is 63, and the cube root of 2W times the cube root of 28 gives us the cube root of 56W. Alright, so we're going to simplify 9 and then cube root. Now 8 will work out to be 2 times 2 times 2 times W times W. And in the second radical sign we have 2 times 2 times 2 times 7 times W. Alright, now this time our index is a 3, so we want to group our factors into groups of 3s. Okay, so on the first one, we're going to pull the 2 out. We're going to go 9 times 2 cube root of W squared. Okay, and then plus 63, we're going to pull the 2 out, so 63 times 2, and cube root, we have 7W left inside the radical there. So we have 18 cube root of W squared plus 126 cube root of 7W. Now, these are not like radicals, okay? Even though they share the same index, they don't have the same radicand, so this is our answer. We leave it now. Okay, so now we're going to move on to our word problem, our final example.